Right, so we have quite a busy day today. We just barely made it with Group A yesterday. We're going to make 3 parts, one by one, and then we're going to assemble them together into this part afterwards. So we basically used approximately 1 hour for each of the parts and then 1 hour for the assembly yesterday. So I'm probably going to cut down a bit on the drawings for the parts just so that we can complete the drawing for the assembly, because we didn't manage to complete it fully yesterday. So what we do is we start a new project. So I click on new there and new single user project. I'm going to find my H drive. And I'll place it in my lecture folder. There's a new folder there. So that's practice task 7 this time. Yeah, I think it's only 2015 on that one. Yeah, that's what I meant. It's only 2015 that works on it. Right, so we've started up a new project for practice task 7. And that's going to be our only project today, because we're going to create all of our parts and the assembly, and everything is going to be created in that one project. So this is when we start to really exploit the fact that we're creating projects, because up until now we've just created one part and one drawing in each project. Now we're going to create more inside one. So the first thing we'll start off with is to create this part, a small plate with 2 holes in it. So we'll go into the new parts, create new file dialog there. We open up the metric folder as usual, and we go to the standard IPT file in millimeters. Oh, it's a Right, so then we've gotten everyone on the same page. So we're going to start a new part, standard millimeter IPT parts. And we're going to start off with this part here. So we need a sketch to begin with so that we can create the outline. So we will start a new sketch, and I usually place my sketches on the horizontal plane. I also don't want it to be on the side like that, so I want to flip it to get it the correct way around. And what we can do today is to create a slot right off, so that we can use one of the drop-down options in the rectangle function. So if you go down here, we have the slot option. And what we can find in our drawing is the length between the center points here, and also the thickness of the plate, so that we can use the slot option where we go from center to center and then give the width of it. So I'm just going to find the drawing here and show it. So the length between the centers is going to be 65. So we go down here, we use the slot option, center to center. And right now I'm just going to place it somewhere in my coordinate system, and I'm going to make it horizontal. So I place the first point, and I pull over horizontally, make sure that I get this horizontal mark so that it's locked into a horizontal position. And I punch in 65 as the dimension. But I also have to remember to hit the tab button so that I get the padlock beside 65 dimension. Because now it's locked into place. Before I get the padlock there, it's not locked into the 65 dimension. Once that is done, I hit enter or my mouse button. And now I get to set the width of it. And the width is going to be 35 millimeters. So I just punch in 35, and I hit the tab button to get the padlock beside it. So I hit enter. So now the size of my slot has been locked into place with the 65 and the 35. So the size is locked into place, but it is still green, which means that we can actually grab hold of it. So if I just exit the slot function, I can grab hold of it and I can drag it around. So I can move it wherever I want to. That's not what I want. I want to lock it into the center of my coordinate system. Because I want, once I go out and extrude it and get a 3D model, I want my planes to be going through the center of this part. So then I use the constraint options, and I go for the coincident constraint, which is going to attach one point to another point, or a line. And I find that green dot in the middle of my slot, so the midpoint there. I click that one, and I attach it to the center point of my coordinate system. And now everything becomes dark blue, so that it's locked into place. Now, the fact that we've done this, locked it into the center of our sketch, is going to help us when we're doing our assemblies, because then we are going to need to use those planes that are going through the centers. So then we finish the sketch. We'll zoom out a bit just to get to see it properly. And then we click on Extrude. And this plate is to have a thickness of 12 millimeters. So I punch in 12. And I hit enter. Now we're just going to look a bit at the planes. So I'm going to make them visible just to show you. You don't need to do this. But here we can see we've got one plane going along the z-axis through the center of my part, and I've got one plane going along the x-axis also through the center of my part. And since I extruded in only one direction now, so I only extruded upwards, the horizontal plane is on the bottom of my part in this case. That's not really a problem in this part, but sometimes it might be useful to be able to have the horizontal plane also centered inside your part. And I'll show you on the third one, this one, I'll show you how you extrude both ways instead of just one. So now we're going to create the two holes, one hole on each side. And since we've already got these rounded edges, we can just use the hole option up here. And we can go to the placement option and choose concentric. And then the first thing we're going to choose here is the plane. And that's just the surface where we're going to drill our hole into. And the surface we're going to drill into is, of course, the top of our plate, in this case. So that's the surface we need. And we see it's already starting to draw in a hole here. It doesn't quite know where we're going to put this hole, but it knows that we're going to put a hole on this surface. So the next thing it needs to know is the concentric reference, and that means it needs a radius to be able to put into. So if we just mark the radius on the edge here, then we can also see as we hover our mouse across it, we can see it creates a small cross over here. That's the center point of this radius. And it's now going to, when I click here, it's going to center the hole on that mark. So it moved it over there. Then I can set the dimension, which is supposed to be 12 millimeters. So a diameter of 12 millimeters for this hole. Then I'll click apply, because we're going to place another hole also. So if we click apply, it keeps the window open. It's not a problem if you press OK, then you just open the hole function again. Now, considering that we have a plane going through the middle there, we could have just used the mirror option to get our hole over on the other side. But that's actually almost going to require more work than just creating a new hole when it's just one hole. So in this case, we'll just create one hole manually. Again, it wants us to give the surface that we are going to drill into. And we pick the top of our plate. And then it wants the concentric reference, which is the rounded edge there, and we can again see that it's made a small mark where the center of the rounded edge is. So we click on that and it moves our hole over to the center. And it has remembered that we used 12 millimeters in diameter on the previous hole, so it's set 12 millimeters on this hole also. Then we click OK. And we've gotten our entire part. Now I can't stand having visible planes like this, so I'm going to remove them again. Because if you have visible planes in the 3D parts, they're still going to be visible once we put them together in an assembly, and that just looks pretty stupid when you have lots of planes showing everywhere. So I'm going to remove the visibility again here. It was just to show you how it works. Now we only need to set the material. So we go up to the drop-down menu for materials, and we pick stainless steel for this one. And once we do our assembly, we're going to specify that these parts are going to be welded together. And then it's pretty important that we have the same material for each part, or else it's going to be very difficult to get a proper weld on it. So we put stainless steel on this part, and then we save it. So I'll call this one, we have basically two base plates on this part. One is the large and one is small, so I'll call this base small. And then I click save. And I just leave this one open. We're going to create the drawing for this one first. I'm going to, once we've started creating the drawing, I'm going to skip the part where I fill in the title field and do the general tolerances and stuff, just to save some time, to get better time when we get to the assembly instead. We've done loads of drawings now with the general tolerances and everything, so we don't really need to repeat it in the lectures anymore. So the next then will be to create our drawing. So we click on the new sheet up in the corner there, and we scroll down until we see the usual one that we always use for our drawings, ISO.IDW. And then we click create. And since we have our part open down here, it's going to automatically choose our part for us when we try to set our base view into the drawing here. So once I go up to my base view there, click it, it automatically selects base small, which was the one I just saved. So then I'm going to flip it a bit, just to get to see it from this angle. And then I need to create a projected view, because I also need to put the dimension on the thickness of this plate. And if I put the projected view on this side or up top or below, it doesn't really matter. I'm going to just only dimension the thickness on the projected view anyway. So I think I'll put it over on the side here. And the scale could be a bit bigger, because we're not really using as much as we can of our sheet in this case. So we'll try 2:1. We can definitely use 2:1. We'll just look at 3:1 to see if it's going to fit also. 3:1, that's going to be a tight squeeze for our dimensions. So I think I'll go back to 2:1 instead. So 2:1, then we have plenty of room to place our dimensions in here. And I click OK. And then I just drag and drop the views a bit more up here, just so that I get some more space below them. The next step is to go up to the Annotate toolbar, because now we want to set some symmetry lines and some center marks. So I'll start off with placing the center marks, like this one. And then we have to remember to both put a center mark on the curved edge of the plate and also on the hole. Because if I only put on the curved edge of the plate, then I only get 3 lines. I don't get a line extending out on this side of the hole. So I have to also click on the hole to get that third line and that fourth line extending there. On the other side, I can show what happens if we only click on the hole. So if I only click on the hole, my lines won't extend all the way outside the parts for the curved edge there. So that's why I also select the curved edge. Because now there is no way of misinterpreting this, because we have a center mark that shows the hole, and it is in the exact same location as the center mark that is showing the curved edges, which means that they share the same center line in there, so that they're placed with placed on the exact same point. So I'll just let people get a chance to catch up a little bit. Right, the next part will be to place in center lines to show where we have symmetry in our parts. So we go up to the center line option up top there, and we click on that one. And first off, we have symmetry going horizontally through our parts, because we could mirror it across here. But we also have symmetry going vertically, because we could also mirror it this way, which means that we're going to put in both of those lines. So I'm just going to create it from the edge of this center mark and to the edge of the next one. That's going to give me a horizontal line going all the way through my part. And then I need to right click and do create afterwards before I do anything else. Then I'll create another line going vertically through my entire part there, and I right click and do create. If you don't right click and do create, it's going to create a circle and try to do a funky looking stuff. That's because if you have holes that are in a circular pattern, so you have holes evenly spaced in a circle, you can use center line and just pull a line between all of the holes, and it's going to create a nice design around it. Just to finish it off, we're also going to put the symmetry line across our projected view. And if we're going to be super technical about it, we could have a vertical line on the projected view also to show symmetry, but then we're starting to show absolutely all planes where we can have symmetry. That's not really necessary on this one. So now we've gotten the symmetry lines into place, we can start putting in our dimensions. So I put a general length dimension between my center marks. And I remember to switch the formatting to method 1B so that I can avoid those .00 measurements. And then I get to show that I have 65. And since I also have the symmetry line in the middle, we know that this is going to be centered. So I place the 65 length. Then I am also going to give the thickness of the plate over on the projected view. So place that one. And then I pull my mouse pointer over to my previous dimension there, just so that I can get a dotted line and get the new dimension locked into place in the same position. And just a small thing like that, it might seem that people are sticklers with details, wanting to have it look like this, but it actually makes the drawing easier to read, because you get these systematic placements of dimensions, and it makes it easier for your brain to process when you're trying to read it. So by avoiding having different heights on the dimensions that can be placed on the same line, that's a better way for your brain to handle the drawing when you're reading it. Now we need one more dimension, and that will be the height of the part. And whether or not we put it on the base view here or if we put it on the projected view, that doesn't really matter. We might as well put it on the projected view. And then you can either put it like this, so that you get a diameter sign on it, because then it's going to show the diameter of this one. Or if you've chosen the bottom line and then the top line, then you would get just 35, because then it's just showing the length between those two lines. Doesn't really matter which one you choose here. And then we need to place the dimension for our holes. So then we're going to use the hole and thread function. So we click on the hole and thread function. I click on one of the holes, and now it's not in method 1B anymore. So I'll go up to formatting, and I'll switch it to method 1B. And I'll place my dimension down here. For this kind of dimension, there is no possibility of locking it into the same line as the other ones. So that one's a bit more difficult to get in the correct spots. And we remember that when we placed these holes, we used the hole function twice. So we placed two individual holes when we placed it, which means that when I double click my hole dimension here now to put in the quantity note to show that we have two holes, I'm going to have to do some extra editing. Because if I just double click it and place my quantity note in front of the text here, so this one is the quantity note. So if I just place that one there and click OK, nothing happens. because when I created this hole, I created only one hole. I didn't create more. I pressed apply or OK before I created the next hole. And then I basically started afresh creating holes. So what I have to do is to go back in. I have my quantity note in place here. So what I do is I press edit quantity note. And then I have the option of choosing the number of like holes in this view. And that means that Inventor is going to look at this entire view, and it's going to count all of the holes that have a diameter of 12 millimeters and going straight through. So if I choose that one, then it's going to count both of my holes instead. Then I click OK, and OK again. And now I've got 2 times a hole with 12 millimeter diameter going all the way through. Now usually we would have put in general tolerances and surface finish, parts list with the material, the break sharp edges note, and we would have filled in the title field. I'm not going to do this now, but you are free to do it in the breaks or go back to these drawings and fix it later on if you want to. But I'm skipping it now in order to have a bit more time when we're doing the assembly itself, which is going to be completely new for you guys. Because yesterday I had to rush the last parts of the assembly, and that wasn't all that fun. So I'm just going to click Save on the drawing. It automatically gets the same name as the part file. So I click Save there. And then we're not going to create a new project like we're used to. We're just going to create a new part file, because we're going to stay in this project. So a new part file, the regular standard in millimeters IPT file that we always use. And I click Create. And you can see I've kept the first part and the first drawing open down here. Inventor can have quite a lot of tabs open with different parts and drawings. So it's not a problem to just keep them open. And the next part that we're going to create is the other base plate for our assembly. And as we can see on this one, it has symmetry going horizontally across it when I'm holding it like this. So we could create either the bottom and flip it over to the top, or create the top and flip it down as the bottom. So we can use mirror functions when we've created the outline. So we'll start a new sketch. I'm placing this one also on the horizontal plane. For the third part, I'm actually going to use one of the vertical planes, just to show you that it's not a problem not using the horizontal plane. That's just my habit of doing it like that. And the first thing I want to do for this part is to create the symmetry line itself. And it's been a while since we've done that in any of the practice tasks. So that means I select the line function, and then I go over to the side here, over to the format part, and I also click on construction line, because that's going to give me a yellow dashed line instead. Then I'm also going to flip my view here, just to get it the right way up. And now I'm going to create a horizontal line, because I basically want my part to look like this when I'm done drawing it. So I'm going to create a horizontal line, starting off, pulling it over to the side, making sure that I get this horizontal sign here, that it's locking it into place. And this one is going to be, let's just get the dimensions up here. This one, symmetry line, will have the same length as the part, so it will be the same length from here to here as the part is going to be. And that length is 100.7 millimeters. But before I do anything else, I must remember to click my tab button to get the padlock in place. And now we can see that something happened to my line. It's no longer 180 degrees and locked into place as a horizontal line. It's now at an angle. So now I have to zoom out a bit. And I have to make sure that I get this horizontal lock into place again. Yeah. Once I've placed the line, then I'm done with construction line and the line function for now. So I'm going to hit escape to escape the line function. Now the line function isn't marked blue anymore. And I have to go up to the construction line option, and I have to click it so that it's not blue anymore there either. Now we want to make sure that for this part that we're going to get one of the planes going straight through the part here also. And that makes it very important that we use the coincident constraint to place this line onto the center point. So we go up to the coincident constraint up there, click it, and then I go down and I try to find the center point of my line. It's going to show as a green dot. You even get the middle point text up when you hover above it for a while. I click on it, and then I click on the center point of my coordinate system. And now it's locked into place and it's turned dark blue. So now we have our symmetry line, and the symmetry line is the same length as our part is going to be, which means that when we start creating the outlines of our parts, we can attach them to the ends of our symmetry line. So it's going to give us the starting point. And we want it to look somewhat like this, which means that we are going to create a line that's going vertically up here and a line that's going vertically up here. We're going to have this line start at the end of the vertical line here and go upwards, and then it's going to go into a radius curve and attach to the other side. So the way we're going to do this is to, first off, we're going to start in this end and start creating the vertical line. So we go into the line option, click that one, then I'm going to attach it to the end here. I'm going to pull it upwards and make sure that I get my vertical lock into place. And then I'm going to set the height. So the total height here is going to be 35 millimeters. But we're of course starting from the center, from the symmetry line, and going up. So I need half of that, so 35 divided by 2. So then I get the correct length. And I hit the tab button to lock it into place. And then it even shows me the correct dimension. So it stops saying 35.2 and it says 17.5 instead. Then I can click my mouse button or enter to lock it into place. And since usually when you start creating lines, you often want to continue creating lines, Inventor just automatically starts the new line for you. So in this case, we're just going to pull a line a little bit up to the side there at a random location. We don't quite know what angle we're going to have or what length yet, but we're just going to place it there with our mouse button. And it's going to be green for now. Later on, we're going to connect it to the other side of the part, but for now, we're just going to leave it there. So then we click Escape to exit the line function. And what we want to do now is to actually create the curve up top here. So we're just going to create a full circle, and we're going to place it where it's supposed to be. Because then we can do this line, and we can connect it to the circle and make it become tangent with the circle. So first off, I'm just going to place a circle. And I'm going to set it to the correct diameter. Now the radius up top here is going to be 17.5. So then I put in 17.5 and I multiply with 2 to get the diameter. So I think we'll do a break there. We're already past 9 o'clock, so. So we've gotten our circle onto our sketch, and we've set the diameter. But right now it's not locked into place, so we can drag it around if we want to. So we need to use dimensions in order to lock it into place. So one way of doing that is clicking on the dimension option, and what we want to do is we want to have the horizontal distance from the endpoint of our symmetry line and to the center point of our circle. That's going to be the same as the radius of our circle. So we start off at the endpoint of the symmetry line, and we click on the center point of the circle, and then we have to pull our mouse pointer a bit down to get it to show a horizontal length. So we place this one here, and here now comes a new part that we haven't done before. So as you can see here in the window here, it says Edit Dimension, and it says D3. And that means that this dimension has the name of D3, just like in an algebra assignment you would assign a value to X. The value of D3 right now is 23.3500317 millimeters. But that also means that all of the other dimensions here, they also have their own names. And one very easy way of selecting one of those dimensions is not by knowing the name and writing it in here, but just by clicking on the dimension. So if we click on the diameter of the circle, it now says D2. And that means that when we fill in D2 here, inventor knows that right now that is 35 millimeters. If I later on change the diameter here to 40 millimeters, then it's going to change to 40 millimeters in here also. But this is the diameter, and we need the radius here. And since the radius is half the diameter, we can put in divide by 2. So this is just the same as putting in a variable, an x or a y, into an equation. The only difference is that we are defining our variable by changing the dimension up there. We're not going to change the dimension, but that is something we can do. I'm going to show it afterwards, just to show you that it works. So when I click Enter now, it also says fx 17.5. And this means that it's a function, and the answer to the function is 17.5. But if I now change, you guys don't need to do this, but if I change the diameter of my circle now to 40, then this one should become 20. So I go in here and I put in 40, and suddenly I have 20 down here, because now it's doing half of 40 instead. So it's a good way of building in automation in your parts. So now this dimension here will always follow and be the radius of that diameter. No matter what I do with that diameter, no matter how large I create it or how small I create it, it's always going to be the radius of that circle. So I'm going to put it back to 35, just so that we're back in the correct spot here. So now we've gotten the horizontal distance locked in. We also need to get the height between the symmetry line and the center of our circle. So then we do another dimension up here, and I click on my symmetry line, and then on the center of my circle, and I pull it over to the side so that it shows as a vertical dimension. I place it there, and that dimension is supposed to be 112 from the center of this curve down to the center of this curve. But we're doing half of it, so we get 112 divided by 2. And that's going to give us the correct distance. So I'm going to just zoom out a little bit to get to, or zoom in a little bit to see everything better. It's a bit difficult to see right now, but from the end point of the symmetry line and up to the edge of our circle, there is a straight vertical line. And we can get to show that line by creating a new line. So we click on the line function, and we go down to the end of our symmetry line. We attach it to the end of the symmetry line, and we pull it upwards until we hit the circle, and it's going to attach it to the circle here, and we can see that it's a straight line and it has 90 degrees angle from the symmetry line. So here we have a perfect tangent transition over to the circle. Right, so we still have an opening in our outline here. We haven't connected this loose line here to our circle yet. So the first thing I'm going to do is to place it approximately where it's supposed to be. So I'm going to grab a hold of the end of the line with my mouse pointer. I'm going to click and drag. And I'm just going to pull the line up here. Because if I have it all the way over here and I constrain it to become tangent with my circle, it might become tangent on this side instead of becoming tangent on that side. So it's just nice to place it approximately where it's supposed to be. So the next point will be to do a tangent constraint. And the symbol explains itself. We have a circle and we have a black line going tangent to it on the symbol. So we click on that one. Then we click on our line, and then on our circle. And our line is now tangent to the circle. One thing we can see is that the line is not actually in contact with the circle. Or if you pulled your line further up than I did, then it's going to go past your circle right now. So it might be all the way up here, or it might be all the way down here instead. That doesn't really matter. As long as it's hitting the circle once you are extending it or pulling it back. That's not a problem. The next thing we need to do is to use the coincident constraint, where we connect one point to another. So this one, the coincident one. We select that one, and we do the end of our line. And then we click on our circle. So then it gets completely stuck to our circle. Hva tenker du på? Ja. So we're almost ready to mirror our outline, but we don't really need this part of the circle, so we're just going to trim that one away. So we go up to the modify section of our toolbar, and we find the one that's named trim. It's got a nice little symbol of a scissor cutting a line there. We select that one. And now if I move down to the circle, to the area that we want to remove, we can see that it's creating a dashed line between the straight lines. And that means that if I click now, it's going to remove everything that's marked with a dashed line. And it's going to keep the continuous line for the rest of this circle. So I do that. Then we're rid of that one. And now we are ready to mirror it over to the other side. So we go up to the pattern part for mirror. And we select our lines. It is important here that if you do a selection box, so if you click here and you drag and drop across everything, then you have to hold in your control button and deselect the symmetry line afterwards. So your symmetry line is not supposed to be bright blue, because the symmetry line is going to be marked by the mirror line part here. And for some reason, it can't manage to mirror the mirror line. So that's an impossible thing to do in Inventor. So then I click on mirror line up there, and then on the symmetry line. And this is the one where we have to press apply in order for anything to happen. If we just press done, it just exits and nothing happens. Because like in most other functions in Inventor, you can press done and it's going to apply it. But here you have to press apply. Probably a couple of programmers that haven't been talking to each other in this instance. And then we click done. So now we've got the entire outline of our base plate here. Then we can click Finish Sketch. And we can either look at the drawing to see the thickness of the plate, or we can just imagine that since it's supposed to look like this afterwards, this base plate has to have the same thickness as that base plate. And the first one we created was 12 millimeters, so this one also needs to be extruded to 12 millimeters. Now we're still missing the 4 holes going through this plate. And up until now, when we've been creating holes, we've been either using a concentric reference or we've been using edges to place dimensions. But in this case, since we have 4 holes that we want to place, we're going to use a sketch, and we're going to place points inside the sketch in the correct areas where they are supposed to be. And then we are going to create holes on top of those points afterwards. So the points will signify the centers of our holes. So we're going to create a new sketch. And this is a little bit because ideally we would have wanted to have the center of this hole to be on the exact same location as the center of this curve. But that's not the case in this drawing. They're a bit off. So we have to create them in another way. In order to put points into our drawing, we have this option up here, which says point. And for now, we can just place in the approximate locations all 4 points. And you can see that they're green because they're not locked into place in any way now. So I've got 4 green points, and now I need to use dimensions to place them in the correct locations. So I go up to the dimension function, and I'm going to use the end of my plate to give the heights of the holes first. So the length from the end of the plate and to the first hole is supposed to be 20 millimeters. So we put in 20 millimeters. And from the end of the plate and to the next hole, we're supposed to have 42.3. And now we can utilize what we learned with using the diameter of the circle in the first sketch and using that in our equation to set the radius. We can do the same here, but now we're just going to use the dimension straight off. So we'll do the length from the end of the plate and to this point. So this one is supposed to be the exact same length as this one. So we can just click on the 20 millimeter dimension there. And it says D7 in here. So that's the name of that one, is D7. And if I just press enter now, it's going to be the exact same length. And if I change this dimension, this one will also follow. So I do the same for the fourth hole. And I click on the equivalent dimension on the other side. And I get 42.3 for this one also. I'll give people a chance to catch up. So now we've gotten the lengths from the end of the plate and down to our points. And now we need to get the lengths from the center and to our points. So one way of doing this is actually giving the lengths between the points, which we are given in our drawing, and then doing half of that to the center. So I'll do the lower point first, from one point and to the other point. According to our drawing, we're supposed to have 69.8 between these 2 points. So 69.8. Then we hit enter. So now we've locked the distance between these two to 69.8. If I now go from this hole and to the center, this point and to the center, it's not a hole yet. And then I click on my previous dimension here, so that I get D11 in my case. And then I hit divide by 2 because I want half of that. Then I have it centered. So now I have 69.8 between my holes, and they are centered on my plate. So then I can do the same for the 2 top points. I put down the dimension between them. And that one is going to be 102 millimeters. Place that one in. And then I do from one of the points and to the center. And I click on my 102 millimeter dimension. So I get D13 in place there, and I divide by 2. So then it's placed in the middle. I'll try to organize the dimensions a bit more here. So now it's a bit easier to see all of the dimensions I put in place there. So then we can finish our sketch. And we're going to create our holes. So the 4 points that we've now placed, they are telling us where the centers of our holes are going to be. And if we click the hole function, you're going to see that since we have a sketch that's not being used for anything right now and it has 4 points in it, as soon as we click the hole function, Inventor chooses that sketch and all 4 points. So it says, well, I'm betting that this is where you want me to place holes. And in this case, we're also going to have a 12 millimeter diameter. And they are perfectly placed according to our sketch. So when we click OK, we've got them all in place there. So once you've gotten your holes in place, there are only 2 things that are missing. We need to change the material to stainless steel so that it's the same as the first part we created, and we need to save. So we'll pull down the material list, find stainless steel, click on that one, and then we'll go up and click the save button. And once you click the save button, you'll see that we can see the first one we created because we're still in the same folder since we're still in the same project. So we have base small up there, and this is also one of the base plates, so this one will be base large. So the next step now will be creating a drawing for this one and dimensioning it. So the next step is to create the drawing for this part. We'll click on New up in the corner there. And as always, we use the ISO.IDW when we create drawings. And we click Create. And now we have 2 part files open. We have base small and we have base large. But it was base large that was the previous one that we had open and actually worked on. So that's the automatic choice when we click on base view up here. It will choose base large because that's the one that we previously edited. But if we open the drop-down menu here, we can see that it will be very easy to switch to base small if that was what we wanted to do. If we had created all of our parts first off and then we're creating our drawings afterwards, it will be easy to switch between them since they're all open in here. Then you don't have to go into your Windows Explorer and figure out where the file is located. So we're going to tilt this one around, get it up like this, and we want a projected view so that we can show the thickness of the plate. And right now they look a bit small on our sheet, so we're going to try scaling them up a bit, 1 to 1. That looks a bit better. I am pretty sure that if we try 2 to 1, it's going to be too big. But we can try just to be on the safe side. So definitely 2 to 1, that's way too big. So we'll go back to 1 to 1 on this one. Then we'll click OK. we can just drag and pull them a bit to get a bit more free space around them. And as usual, we want to get some symmetry lines and center points into our drawing. So we'll go up to the annotate part of the toolbar. And we can start off with the center marks. And now you're going to see the fact that the center of our rounded edge up top there, it doesn't hit the center of our hole. And this is where center marks truly come into place to show you exactly where things are located. When you have things that are fairly close to each other, but they're not exactly centered on each other. So we put center marks on all of our holes and on our rounded edges. We also have, in this case, a horizontal symmetry line going straight through our part. And we use the center line function to create that one. So we create it from one side and to the other. And we'll create the same symmetry line on the projected view. Then we can start placing dimensions. And since we have a symmetry line, we can place the dimensions across the symmetry line. So we'll start off with the two holes that are closest to each other. And we'll go from the center point of one hole to the center point of the other. And we need to switch to method 1B. So then we get 69.8 instead of 69.80. So we don't need to show unnecessary zeros in our dimensions. Now this is a typical example of where most likely what I would guess in a situation like this is that this base plate is going to be bolted to another structure, and for some reason that structure has these weird dimensions between the bolt holes. It might be that the original dimension has been set in inches. Then you usually end up getting point something in millimeters. So that might be as easy of an explanation as any. But usually, if you're free to place everything yourself, you would have put this one at 70 dimension, because putting in point something in millimeters, that's so really small that you're sort of defeating your own purpose in getting too detailed in your design. But of course, if the centers of the bolt holes where you're going to bolt it to has 69.8 between them, then the holes that your bolts are going through also need to have that. So in some cases you simply have to endure the fact that you're going to put in dimensions where you have point something millimeters. So then we'll continue on with the next two holes, the distance between them. So we get 102. And then we'll also do that for the center marks for our rounded edges. Then we'll put in the radius for the rounded edge. Whether you put it up top or below, it doesn't really matter that much. If you put it down here, it's going to intersect the length dimensions when we place those, but that's not really a big problem. And the fact that we are putting the radius on one side and we have a symmetry line, it means that we have to have that same radius on the other side. So it's not really necessary to put typical behind it or put dimensions on both sides in this case. So then we want to put in a couple of length dimensions so that we can move over to this side. So we'll do the length from the end here and to the center of the first hole. We don't need to give the length to over here, because that's given by the radius already. So if we had put the length from the end here and to this center mark for the rounded edge, then we would have had to either put that length in a parenthesis as a reference, or we would have had to put that one in a parenthesis as a reference. Then we create the length for the next hole. And then we're going to put in the total length. And for the total length, we're going to have to put in the reference for it. So we're going to choose the reference option so that we get the parenthesis on this one. And the explanation for that will come with our next dimension that we are going to put into place. Because our next dimension will be the length on this side. So we've got this 35 length there, which means that the total length of this plate, it's going to be controlled by the fact that we have 102 millimeters between the center points of our fillets, and we have 17.5 millimeter radius on the rounded edge here. And then we go over in a tangent to a straight line that's going to hit this 35 millimeter line. Which means that the total length here is pretty much dependent on how you hit your tolerances on these other dimensions. So that 100.7, that might not be the actual case when you start measuring this one. But putting it in with a reference point makes it very easy for whoever is machining this part to just put a measuring tool on it and look at, well, it's approximately 100.7. And since he can see the parenthesis on the dimension, he also knows that it doesn't need to be exactly 100.7. We're going to do the same for the total height on the projected view. We're going to put that one also in a reference. Because that one is also controlled by the fact that we have 112 between center points, and then we have a radius on each side of 17.5. So depending on how well they hit their tolerance goals for those dimensions, this one might change a little bit. Then we need the thickness of the plate, and we'll try to get that one online with the one of the dimensions on the other view. And now we just need to put in the hole dimensions. And now, since we created 4 points, and then we used the hole dimension, and it created all 4 holes in one go, we won't have to edit the quantity note and tell Inventor to count all of the like holes in the same view, because it's just going to count all of the holes it created with that one hole function, because it created 4 at once. So we use hole and thread. We select one of the holes, and we switch to method 1B. We place the dimension. Then we edit it to get the quantity note in front. Quantity note there. And then we don't need to do anything else in order to show 4 times a diameter of 12. Again, the last couple of steps would be to fill in the title block, have a parts list showing the material, general tolerances and surface finish, and of course break sharp edges note. But we're going to skip those in order to get a bit more time on the assembly. So now I'm going to save my drawing. And we can see that the first drawing we created is also present in our folder. And we click Save. So then we'll start up our new parts, the third and last of the parts that we're going to create today, and that's this one. So we'll go up to the blank sheet up in the corner and click to get a new part. Again, we choose the standard in millimeters IPT file. We click Create. And I mentioned briefly when I started the previous part that for this one I'm not going to choose the horizontal plane, because I'm basically going to create it like this in the planes here, but I want to do this outline when I'm drawing it, which means I'm going to choose the plane that's going vertical along the Z and Y axis. So I'm going to place my sketch there. Yeah? Not at all. This is just to show you that just because I use the horizontal plane almost always when I create a new part, it's not a problem using one of the other planes. So it's the only difference is that when you zoom out for your part and you're looking at it from the corner, so that if we're looking at it like this, so that you've got top, front, and right, your part will probably be looking like this instead of like that. So it's not a problem at all. It's not going to affect it once we put it into the assembly or anything like that. It's just sort of to break up the fact that I've only used the horizontal plane up until now when I've been creating sketches. So I'll start off with creating the baseline for this one, so just the bottom of it. We'll do that before we go to our break. So I choose the line function. And in this case, it's not really all that important that we get it centered on it, so I can start off with this edge placed on the center point and then just pull my line to the side. And it's supposed to be, let's see, it's supposed to be 137 millimeters long on that one. And we have to remember to press our tab button to get the padlock in place for the dimension. And then we click Enter. So then we've got a start for our part, and we're going to continue on after the break.